Okay, here's the video you'll use, the Nearpod lesson you'll use to grade this. I'm going to do this. It might seem a little bit strange, but what I'm going to do is I'm going to give the answers for 1, 2, and 3 right at the start of this video. And if you got all 3 of those right, you can move on to the next video slide. But if you missed any one of them, you should fast forward to the part of this video you need where I'm going over them. The probability for number 1 is 1/495th, 1/495. Number 2 is 1/25th, and number 3 is 1/286th. I'm going to do them in order, so if you need help with 1, just keep watching. If you need help with number 3, for example, just scroll ahead to that part that you need. Well, number 1 says you select a card at random from those below. Without replacing the card, you select a second card at random. So I know right away these are dependent events. Without replacing either of the cards you have selected, you select a third card at random. What is the probability that you have selected the cards T, H, and E in that order? It's going to be probability of T, H, E without replacing the T or the H after I pick the T and then the H. So it's the probability of T multiplied by the probability of H after T multiplied by probability of E after T and H. So the probability of T, there's more than one T. There are 2 T's of the, I think they told us how many cards, but no, maybe not. Let's just count them. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. There's 2 T's out of 11 cards, 2 favorable outcomes out of 11 possible outcomes. But if we select a T and do not replace it, you have to cross off one of these T's or cover it with your thumb. The other T is still in the bag. Okay, so then we want to draw an H. Well, there's only one H, but there are no longer 11 possible outcomes because remember that first T did not get replaced. So there's a 1 out of 10 probability of getting the H. Then the H doesn't get replaced and we want to pick an E. There's one E, but now there are no longer 11 or 10 possible outcomes. There are 9 because 2 tiles have been removed and not replaced. So 1/9. The 2 and the 10 have a common factor of 2. So that becomes a 1 and that becomes a 5. 9 5s is 45. 45 times 11 is 10 45s or 450 plus 1 more 45. So 450 and 45 is 495. 1 times 1 times 1 is 1. Hence 1/495th. Pretty unlikely to draw a T, then an H, then an E. Number 2, Mr. Jet. For some reason, this one always is one of the hardest ones. I've never quite understood why. Mr. Jaffe randomly chooses one of 5 toll booths. I know why. You don't have a lot of experience with toll booths, or at least not driving through them. Mr. Jaffe randomly chooses one of 5 toll booths when entering a toll road on his drive to work. So in other words, you have to go through these toll booths every day when you're going to work. You can go in any lane you want. What's the probability that he will select the middle toll booth on both Monday and Tuesday? So if he's choosing a toll booth at random, or if you can assume he's like a logical person and wants to get through quickly, if he just picks the one with the shortest line, assuming they all have equal probability of having short lines, which probably isn't true. There's probably some psychological thing about which lane to be in. But in any case, if there's a random choice here, there's a 1/5 probability of picking the middle lane on Monday. When he drives up on Tuesday, the fact that he picked the middle lane on Monday does not influence his probability of picking the middle lane on Tuesday. It should be equally likely if he's randomly picking a lane. So there's again a 1/5 probability. Those are independent events. When you multiply a 5th by a 5th, you get 1/25th. A farmer buys individual letters. These are actually available. If you're ever in Lowe's or Home Depot, you'll see that there are individual letters available to make signs. So a farmer buys individual letters to make a sign saying no trespassing. So he needs an N, an O, a T, an R, an E, an S. Actually, a lot of S's, right? There's 3 S's, a couple N's. Okay, on the way home, 3 of the letters fly out of the back of the farmer's pickup. 3 letters at once fly out of the back of the pickup. what is the probability that he lost all 3 S's? Now we have to treat this the same way we would treat it if one letter flew out, and obviously wasn't replaced because it's not going to fly back into the pickup truck, and then another one flew out, and then the third one flew out. Even though they're happening all 3 flying out at the same time, you treat it like one after the other, because the second letter cannot be the first letter. So these are dependent events. So it's the probability of S, 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 which equals the probability of S multiplied by probability of S after S multiplied by probability of S after the first 2 S's. The probability of the first S falling out, there are 1, 2, 3 S's. So 3 favorable outcomes out of, I don't know how many possible outcomes because I need to count these letter tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Lucky 13. Once that first S is out of the truck, the chance of the second S, let's just cross out an S. There's only 2 S's left, so there's 2 favorable outcomes out of 12 possible outcomes because there's 1 fewer letter tile in the truck. And once that S is gone, there's only 1 remaining S of the 11 remaining letters. And so this is our expression. 2/12 simplifies to 1/6, and that's it for a common factor. Oh, I take it back. 3 and 6 have a common factor of 3. 3 becomes 1, 6 becomes 2. 1 times 1 times 1 is 1. 13 times 2 is 26, and 26 times 11 is 260 plus 26. 10 26s and 1 26, so 286, 1 out of 286.